Hello, I'm Adam Turleson, and today I'm excited to present Agentic Chartering, an AI agent architecture that enables the agent to create on-demand, deterministic orchestration by producing a charter, a declarative document that can be interpreted as a finite state machine. The agent's reasoning model understands the goal and passes it off to a coding model to create a custom tool to complete the task. This tool composes together predefined and pre-approved functional primitives made available in a registry. This design has many advantages. Compared to agentic orchestration, where the LLM is given a list of tools and is tasked with chaining one tool call into the next, chartering can be up to 99% more context efficient. It's also way faster and more reliable when executing a sequence of steps because you're leveraging code to do the orchestration, not the AI model, the right tool for the right job. Compared to other approaches that use code gen like Anthropic's MCP code mode, this architecture does not introduce the security and operational complexities of deploying an agent into an environment where it is able to write and evaluate arbitrary code using a full-featured programming language like Python or TypeScript, which generally forces the use of a sandbox. With agentic chartering, no sandbox is required, and yet the operator has complete governance and security control. This is basically the architectural equivalent of an agent that is able to create and execute AWS step functions on the fly to achieve arbitrary goals, where the individual steps in the machine can be atomic operations, another state machine, or even a sub-agent. And this has some pretty amazing effects. So let's take a look.
Here I am in our test environment for one of our products at Navion Logistics called KeepFill. We help our customers monitor the level of fuel and tanks at gas stations and do sales forecasting to predict and prevent runouts by creating, scheduling, and managing orders through their life cycle so the right product with the right fuel is delivered to the right tank at the right location at the right time. Here I'm looking at a store detail page, and I have our old chatbot wired up that uses agentic orchestration available to help me manage this site. So let's begin by asking it a basic question. How many orders are there? Well, that works. I'm going to bring in temporal so that we can observe everything that happens in the system. So it came back with a result of 16 orders, but let's look at how it actually achieved that. So the message was received from the user, and then OpenAI's responses API was invoked, where it determined that a tool call was necessary. It performed that tool call and then passed the response back into the reasoning step. Now the user only asked for the number of orders, but let's look at the payload that it actually received. It received information about every single detail of the order, despite that having not been relevant for the user's request. So now let's ask it something else. For each tank, give me the 5 most recent readings. So here we go again. We received the message, and it calls in and determines that tool call is required. It calls that tool, passes it back to the reasoning step, calls another tool, passes that back to the reasoning step. Then it uses parallel tool calling to actually go and get all of the recent events for all of the tanks one by one, and then merges all of that information back into the reasoning step, where now it's going to come up with a response after a little bit, because this is a lot of information that's being passed in, so it can take a second to come back. So it's been about 30 seconds later, and we got the result. It's correct. It worked. But let's also consider that this chatbot is also limited in its scope. It is only operating on the data related to a single store. Now, we made this change because we ran into the scaling limitations of our data model, and the chatbot was simply not able to handle the amount of context that it was being passed through tool calling such as this when the number of entities became exceedingly large. Now, let's contrast that with our new Navion assistant that uses agentic chartering instead. This chatbot was built by taking every temporal activity and workflow that we had developed and making them available in a registry that is provided to the coding model. It has about 120 tools described in a couple thousand lines of metadata available for use. So let's begin by asking it the same question again. How many orders are there? Now in temporal, we can follow along as the agent does its work. The first step is a reasoning call to the LLM, where it's going to determine that a tool call is necessary. Except this agent, in fact, only has one tool called run charter, which invokes the chartering workflow. That charter is actually emitted once it's produced back to the user so that you can view and understand what's going on. You can see the goal that was passed in, count the orders for the caller's organization. There were no data inputs, but here's the result that it got, over 30,000. The charter can actually also be visualized, so let's take a look. It looks like it found an activity called get orders count all that returned exactly what it needed. That's terribly convenient. Let's try again with a query for something a little bit more abstract. What are the next 10 upcoming deliveries to stores at a zip code starting with 55? So we'll watch this work. While this is running, we'll take a look at how the chartering workflow actually functions. So the chartering workflow has 4 phases. It begins by making the charter. This is where the goal is combined with information from the registry and passes them to GPT-5.3 codecs via the responses API. The model is outputting the charter JSON. From there, it is statically analyzed, and then automated tests are run against it using mock data. If any of these quality checks fail, the specific error is given back as feedback to the coding model to try again. So here it got the result for the next 10 upcoming deliveries. Now let's have it perform an update. Update all orders scheduled in the next 5 hours to have 1 more gallon added to each order item. Here we go. And I'll navigate back so that we can watch it work. Now, here you can see that it did something a little bit interesting here. The model actually decided to fire and forget this update goal because there was no follow-up activity for the reasoning model to do. So while this charter is running, I can actually continue my conversation. Hi there. All right, so I sent my message, and in the meantime, it looks like the chartering workflow made it far enough along where it made its charter. It looks like it failed static validation a couple times, so it took a couple turns to create the charter, and then there is a deterministic check that looks at the charter and determines whether it is using what are called risky tools out of the registry. And if any risky tool is leveraged by the charter, that charter is passed back to the user for their explicit approval. So before I do that, I've also exposed to this chatbot the temporal API. So I can ask it, what is the status of the workflow to update the order item amounts? So we can ask it, it'll then reason about that, invoke another tool, and hopefully come back with the response that it is still running. So we got the response back. Here's the information exposed to the charter. Looks like it wanted to take another turn, and we got it. The update is currently running. All right, so now returning back to our risky charter that's still sitting here pending, awaiting approval, I'll hit the YOLO button to let that go, and we'll watch this work in detail. So here I got the approval, and now it has moved forward into dispatch. In dispatch, there is a simple interpreting loop. As I get myself in here, there is a simple runtime loop that interprets this charter as a workflow. The workflow itself is pure orchestration logic, and all side effects happen in the activities. The state machine, the charter, acts like a traditional orchestration service by playing traffic cop, not by actually performing any of the work directly. Every command referenced in the charter is executed either as a workflow or an activity call. So you can see all of those updates sequenced here. Now, if we take a look at the charter, you can see that things have gotten much more complicated, and there's an expression node. So just like in AWS step functions, JSONATA is used to essentially provide data mapping from one node into the next. And in temporal, I've configured those node types for expressions to run as local activities. So those don't need to round trip into temporal cloud where your traditional activities or your typical remote activities would. So all of that was executed, and we got our updates performed. So now let's really have some fun. So since we've basically given our agent the power to delegate goals with a single tool call and not have to perform the orchestration itself, it can now use agentic orchestration and parallel tool calling to effectively execute extremely broad compound work that leverages both agentic chartering and orchestration. So I'm just going to paste all of this one in here, and then I'll read it out loud. In parallel, answer, how many stores are there in Minnesota? What tanks are in group 761? Insert a new reading for tank ID 837 for 8,000 gallons at 8 a.m. CST today. How many active stale reading alarms are there? Then, after all that is done, send an email to the store manager at store ID blah with a summary with all of the previous answers. Whew. Let's go watch. So it is reasoning about that right now. So let's just wait a moment. All right, there. In temporal, you can see the agent has launched multiple charters in parallel using promise.all. When they complete, the agent is informed about all of those responses and can use agentic orchestration now to formulate what happens next. So it emitted now, it completed all of those charters. One of them was flagged as risky, so I'll go ahead and approve that so that we can keep moving here. That one now successfully completed. It passes all of those first responses back to the reasoning model, where hopefully it'll determine that one more step is required to send an email There it comes. We emit that charter 2 for visibility. Looks like that's a risky operation, so I can see all of the information that is being summarized for the store manager. So I'll approve that. That now completed successfully. All tasks completed, mission accomplished.
I believe that agentic chartering is a very significant unlock in agentic autonomy and capability. This architecture allows operators to reduce costs while applying effective and reliable security and governance controls around AI agents, including data access, token usage, policy controlled actions, prioritization, and many other aspects of production operations at scale. To learn more, read my publication on agentic chartering at bluefolders.ai. Thank you very much for watching. Have a great day.